This is the 2018 Junior Cert Higher Level question 2 looking at rotations. Question: the elevation plan and 3D graphic of a logo for a hot air balloon club are shown. The logo is based on a regular pentagon ABCD and tangents QP and QR to the circle at points P and R respectively. Draw the given elevation and plan. So we're going to start with that part first. Then the next part of that will be the logo is rotated through 40 degrees about point O as shown by the broken line and plan. Part B, project an end view of in the direction of arrow A to show the logo in the rotated position. As our arrow A is looking in from the left hand side, we're going to need space on the right hand side when we're setting up our question. So I'm going to start first by setting up my elevation off over here on this side of the page, as I need space for my end view off over here. And the total width of this is 50, 40 and 50, so 140. So I'm going to mark that 140 first. And we're given a height up of 15 first, so from the ground up to the bottom is 15. And then it's 85 up to the curve. So I just need to find halfway now along the 140, and that will give me the position for the arc and another center point that I need. Now what we're going to do is we're going to add the curve, the arc to the top of this. If we follow the radius line down, we find that our center is at this point in here, so that's halfway along our bottom line. So I'm going to draw an arc that is the correct radius, so it needs to just touch that point up there, and that's going to give us our position. So this is our top arc drawn there. So I can just darken in the outline now of this first. This gives me the outline for the sign, and I'll find the position for the leg that it spins around in 50, so that gives me that position here. So that's the main outline block of this. The next part of this is to draw the pentagon. So once we have the pentagon drawn, we can find the radius for the circle, which will then allow us to draw the tangents and everything else up in that section also. So next we're going to find the bottom of the pentagon. It's up a height of 30 millimeters from the bottom of the sign, not from the XY line, so up from 30 from this line here. And we need to find the center, which I already have, and we're given a side length for the pentagon of 40. So D to C there is 40 millimeters, so 20 millimeters either side of my center line gives me a side length for my pentagon. So I'm just going to pause the video here for a second and zoom in on that area so it's a little bit clearer. Now, so that should be a little bit clearer. So next what we need to do is we're going to draw our pentagon. It's a regular pentagon, as it tells us in the question, and it has a side length of 40. So we're going to now measure our angles that we need for our pentagon, our angles which will be 72 external. So from 0 up along this way here to 72. 72. Same on the opposite side. 0 up to 71, 72. So that's also 72 there. So I can draw in these two sides lightly again. And I need to copy the side length now. So each side length is 40. So I'm just going to measure 40 millimeters up along from that point here, giving me this one. And this point here. You can also set your compass to 40 millimeters if you like, and that might speed it up. It'll also be quite useful for this next part. So if I set this to 40, just to get the top point of the pentagon from each of my 2 points here and here, giving me the top. So I can just join these points up now, and that'll form the top of my pentagon. So all of this is drawn lightly as we only use the pentagon to form the star, which we'll need in a moment. So that's our pentagon. Now we need to find a circle that is going to be touching off of all of the points there. So if I bisect, each side here is a chord, so if of that circle. So if I bisect any two of them, this one down here is already done for me. So if I bisect any one of the other ones, where that crosses the first one, will give me a point on the circumcenter. So bisecting it, if it's 40 long, find halfway, that's 20. And I can just join that to the opposite point. And same for the one at the bottom, from the center to the opposite point. That there's the center of the circle. So now we can draw our circle around this. Again, draw it lightly to start off with, as not all of it is going to be darkened in later on. So that's our circle. The star is drawn in the center of this, and that's drawn quite straightforwardly. So from apex, from joining opposite corners of our pentagon, that gives us our star. We can darken in the appropriate lines on this. So from our corner until it crosses each one, crossing there in the center. Same coming down from the top. So that's the star drawn in the center. Next part of this, we need to draw the two tangents to the circle. So coming from a point here somewhere down to this point Q, and from Q up to a point here somewhere. So our construction for this is quite straightforward. It's our basic construction for a tangent from a point outside. Join the point to the center of the circle and bisect. So joining point at the center. From here, I swing an arc so that it touches. That's equal to half the length of that line. It's going to cut the circle in two places on either side of it, and they will be the points of contact. So this line can be joined back down here. So from my point of contact down to Q, stopping where it crosses the bottom line. Same on the opposite side. So light line up along here, and that gives me the other tangent. So you can darken in the outer circle there, and that will be most of the elevation completed. So just finding this again, it was based on the standard finding a tangent from a point outside of the circle, join the center to the point, bisect the line, and then swing an arc equal to half the length of the line. That'll cut the circle, in this case on either side. So the final part of the elevation is the bits coming out here at the side, and then we have an arc to put on down here as well in a moment. So what we're going to do first is looking at the question. We can see that the top band there comes out from E and B, and then it's 10 millimeters down each from them. The end of them is found by joining a line from the top of our arc, so from the corner of our arc up that 85 down to the rotation point. So our end point is found from joining here down to here, here down, and would be the equivalent point on the opposite side. And we're going to be, this is the top of it, and down 10 millimeters below that each time. So down 10 mil each time. So So just need to find the same point on the opposite side. So from this corner down in here, found our heights. So now we have just one final part in the elevation to complete. The final part of the elevation that we need to set up is that small grey section on the bottom right hand corner of it. We're told that it has a radius of 80, but we don't know where the center point is. We can locate it though. So we are given 2 points on the curve. We are given the top right corner, so it's up 30 millimeters from the bottom, and then we're also given the bottom left corner towards point Q, and that's out 50 millimeters. So what we can do is, as I was saying, we have this point here, and we also have this point as 2 points on the curve. We know the radius as 80, so if I set the compass to 80 millimeters and swing an arc from each of these 2 points, wherever that wherever they cross will be 80 millimeters from both, and I can draw my arc then. So just going to set up a line here to measure 80 millimeters on. So from this point, swinging an arc of 80. So swinging an arc of 80. Same from the other point, swinging an arc of 80. And where those two arcs cross, this point here is a point that is 80 millimeters from here and from here. So I can now draw that arc and it will touch both points. And there we have the elevation. The next part of this is we need to find the plan. We're still in part A. We need to find the plan, which is the dotted line, the straight line and the dotted line. So I've come down quite a distance here just to give myself enough space. The overall width of the object before it's rotated is this wide. So I can darken in that part of it. That is the true plan. Then I need to find the center point where it's going to rotate around. So that would be this point here. And then from when I have that, I can find the line at 40 degrees as given in the question. So it rotates into a position of 40 degrees. So measuring from here around 40. So just lightly first. So this is where we need to now work out the length of it. So it rotates around that point. So the length of it isn't going to change. This one is going to swing up to here. And around the same point, this side swings down. So we have our dotted line running along here, and that is the new plan after it has been rotated into its new position. So that completes part A. So to draw the elevation and the plan after it's been rotated. So now we're going to look at part B of this, which is project an end view in the direction of the arrow A to show the logo in the rotated position. So first thing we're going to do is we're going to set up our end view, find its position, and we're just going to be operating off the dotted line. So that's the only line that we take over for our end view. Every other line, when it comes down here, will need to come onto our solid line first, be rotated onto the dotted line, and then it can come across into our end view. It can't go up into the end view until it has come off this dotted line, the dashed line. So first I'm going to take the position, the full width for our dashed line. So taking that full distance, bring it over to the extreme edge of this here, and then projecting that up into the end view. So this is going to give me the full width of the object, and I'll find the base point of it also. So this is the lower part of it. So this bit along here, up as far as the top of the arc, here and here, I can darken in as solid lines. So that gives me the full width of the object, how high it is up off the ground, and I can also find where the rotation point is. That axis is this line here. So what we're going to do first is I'm going to find this arc up here, what it's supposed to look like over in the end view. To do that, I need to locate a number of points on it. So this is going to be a point. I already have my 2 points here, so if I found 2 more points here somewhere in the center, it would really help me along with that. So what I'm going to do is I'm just going to pick a random height here, draw across it, and that's going to give me 2 points here and here. So I'm going to label these points. I've got 1, 2, 3, 4, and 5. And that should be enough points. I already have 1 and 5, so bringing this down, rotating around, this is 1, and this is 5. Point 3 is the top point, so that needs to come down onto the horizontal line first. I rotate it around the axis here onto the dotted line, and only when it's on the dotted line can I project it into the end view. So point across and projecting it up into the end view. The height is going to remain the same, as that doesn't change as it turns around. So this point up here is point 3. Do the same thing for point 2. Point 2 going to be projected down onto the solid line first, and then I can rotate it around the dashed line, onto the dashed line. Once it's on the dashed line, then I can project it up into the end view. I recommend doing 1 point at a time until you get a bit more practice at it, as you're likely to lose track of your points. So 2 came down, rotated across. Up here now I just need to find the height of it. The height stays the same. This is point 2. Now point 4 is at the same height, so I'm going to project 4 now down and find that in plan. That's the original plan. Rotate it around into the position on the new plan. That's swinging down this way. Project that now into the end view. And this is point 4. So what I need to do now is I'm just going to draw my best curve that I can that will touch each of these points and come back down on this side here. And that gives me my curve, this curve here, as this is what it appears as now. Next, what we're going to find is the pentagon, located here. That pentagon is going to help us with the circle, because that will give us 5 points, and then we'll have a couple of other points like the base here, the 2 points of contact, and that should be enough. We might find 1 or 2 more points up here then to draw our circle. So it'll give us enough information to draw all of that. So we're going to take each of our points. I'm going to label my points as they appear in the question. Let's see, this is R, D, P, and E. So just handy to have the points labeled, so when it comes to moving them, you don't get as lost with it. So we're going to take point A first. This is the easiest one. It's top center. We already have the line that it's on, so we bring it down into the plan, rotate it around. We already have that from earlier on, and find that this gives me point A up here. Going to do the same thing now for B. So going to take B down into plan, onto the solid line, rotate it into the new plane, and find that now in the end view. Its height stays the same as it is in the elevation, so B is going to be at this height coming across. This gives me point B. C is going to be done the same way, so locating point C, down onto the solid line, rotate it around onto the new plane, its height stays the same, so locating point C, so follow it down, this is C, rotate it, this is point C here. So we're going to keep having to do this over and over again, bringing our points down, rotating them around. D is on the axis line, so D is going to be here. And then we just need to find E, so E comes down onto the solid line first, rotate it around onto the dotted line. And this gives me point E here. So that gives me the pentagon. If I have the pentagon, I can now draw the star. So each of those is going to be joined up. So A can join to C. So draw them all lightly first. So this is quite repetitive. You're doing a lot of the same procedures over and over again. But that makes it just a little bit easier, I suppose. So darkening the bits now that should be darkened in. So along here. And across the top. So that gives us the star. All we need to do now is locate just our circle. So I already have 5 points in the circle. If I found another 5, it would make it much easier. So the 5 that I'm going to take are points P and R. They're going to be very useful. I'm going to take the bottom point of it down here, and then I'm going to find just a random point up here somewhere. So P and R are going to be at the same height. So they can be coming across there at the same height because they were swung from the same position, centered, and the arc was the same. So locate point P down in plan, project it down onto the dotted line, onto the solid line, rotate it around, and then project that over into the end view. So that's now R. P, sorry. That's P. R is found the same way. Down onto the dotted line. Rotate it around. And this here is P. R. The bottom point, so the bottom of our circle, it's going to be directly below A, so it's going to be on the same line as that, and its height I can bring across from here. This gives me this point, we'll call it S, so that's S, and I just want 2 more then, so somewhere up here, just to fill in the points for my curve down here, then I'll have a decent attempt at a circle. So I'm just going to take, again, 2 random heights. You can use your 30-60 if you like, but it's just handy if you put them both at the same height. And you could also put them directly above D or P. It would have made it a little bit simpler, but that's not important. So follow your line, U comes down along here, comes across this way and up, and it's this line here. So that's point U, and T is done the same way. Follow it down. So this is why it's important to be doing these individually, so that you don't get too many of them going along in one go. So what I'm going to do now is going to join R to E, up to A, back to U and B, and then back to this point here. Now, don't need to go any lower, didn't need to find a S, but anyway, didn't need to find a S as I don't need to draw that part of the circle, because I'm going to have a tangent joining to Q, which is found on this point down here at the bottom. So R joins to there, and P also. So both of them join on either side down to those points. So that gives me the bottom part of that there. So that's a good portion of this done now. So I still need to do the pieces coming out either side and this arc down here at the bottom. Now, so what I'm going to do next is these fan pieces out the side. I've labelled 2 points down here, 6 and 7. 6 is the point joining to 1. It's also the top of the point of rotation. And 7 is the equivalent point on the opposite side. So in 50mm from either side, 6 and 7. I need to find both of them over here, and that'll allow me to draw this quite quickly. So 6 I already have. It's my point here, it's on top of the rotation, and 7 I need to find. So 7 is directly below C, so follow that down and up. So this is point 7 here. So what I'm going to do is I'm going to put in the line from 1 to 6 and 7 to 5, 1 to 6 and 7 to 5, and that's going to help me find these pieces here on the side. So I don't need to go finding each end point individually. 1 to 6, wherever they intersect that line, and this line will solve that for me. So just going to go through this. So 1 to 6, I've drawn that same line here. They come out from, if we take this top point, it comes out from E until it touches that line. The next one is 10mm below that, so that's going to stay at the same height here. I can project that horizontally across from the edge of the circle out to that sloping line, and 2 more from here also. So here across, and the bottom point there also. So this one comes out to meet. So you can do that on both sides. So that gives me this fan part of it coming out along here, and just do the same on opposite side. Do them all in one go. And then just darken in this little stretch of it here. So quite a lot of points to be moving and tidying up, but the principle of this is the exact same. Every single point is moved in the exact same way. If it's a point on a curve or a point on a corner or here, it's done the exact same way. So I take point 4 as an example. Point 4 is projected, found in plan, in the original plan first. It's rotated around into its new position, and then it's projected up into the end view. So across the extreme edge, up at our 45-degree angle, and finding our line on here. Its height is going to stay the same, so 4 comes across, giving me point 4 up here. One more thing that needs to be done, and that is finding this curve here. So we already have point 7. Point 8 is in line with C. So this is point 8. I'm just going to find 2 more points. So I'm going to take this point here, as it's on the line coming from 4, and this line here, because it's on the line coming from R, just to make things a little bit easier. So the line coming from 4, I'm going to take that height of the point. It's in line with 4, it goes here. So I just picked a point here, picked another point here, it's on the line from R. So I can follow that down, it rotates around, it comes up, and it's on the line from R. So it is going to be this point here. So then when I have them, I just join all the points up, and that gives me the curve down in the bottom right hand corner of this question. And there we have it. That is the 2018 higher level question 2 looking at rotations.